The sorting algorithm of focus today is called bucket sort.
Hello, my name is Noah Buly, and I will be talking about the functionality of the bucket sort. So first to start off, we need to ask the question, what is bucket sorting? And so bucket sort is a sorting algorithm that breaks an array into separate sections that are called buckets. And these buckets can be linked lists or vectors. That's just what works best for this sorting algorithm. And there are four basic steps for implementing this sorting algorithm. First, you create your empty buckets. So based on the starting array that you have, you will create certain buckets to help sort the data better, like certain ranges of data that you'll put in each bucket. And then you will insert the values from the original array into their corresponding buckets. Then you will sort each bucket, so like the data within each bucket, how you want that to be sorted. So the example I use on the next slide is like your data being sorted from least to greatest. And then lastly, you're going to connect all the buckets together to have your new sorted array, or you can gather all the data from each bucket. So on the next slide, I'll be going over visualization and kind of a step-by-step on how you go through implementing a bucket sort. So now we are going on to the visualization of our bucket sort. And so for this example, I have an array of 12 integers, and I want to sort this data from least to greatest. And since our values range from 1 to 19 in this array, I thought that it would be good to implement 4 different buckets. So split the data evenly into 1 to 5 being the first bucket, 6 to 10 being the second bucket, 11 to 15 being the third bucket, and then finally 16 to 20 being the fourth bucket. And so since I created this array, I had it nicely come out to be 3 values per bucket, but your buckets could have 1 value in some, 20 values in another, in a real world example, but this is just a nice, easy visualization here. And so once you have all of these values assigned into your buckets, so you're able to take all of the corresponding values from your initial array and put them into the corresponding buckets. You then will sort this data. So for example, in bucket 1, we're able to take 3, 1, and 5 from the original array, and then sort that from least to greatest. So we have 1, 3, 5. And then we did that for each of the other buckets, and then you're able to connect these buckets together or gather the data from all of them, and then have a nicely sorted array down there at the bottom. So yeah.
All right, here we have the runtime analysis for bucket sort. Bucket sort is primarily used in conjunction with insertion sort. So bucket sort is kind of like a pre-sorting algorithm to break apart your data into smaller sections. And then another algorithm, such as insertion sort, is used to actually sort the data in the buckets. So the best runtime is O of n plus k, which is really just O of n. If the elements are uniformly distributed, like the array that we have here, 213, 231, and the bucket sizes are nearly equal, then it's O of n for creating the buckets and O of k for sorting, if we use a linear sorting algorithm like insertion sort. So k can be substituted with n, so it's really 2 O of n, and since we don't care about coefficients, it's just O of n. The worst case scenario is when the elements are in reverse order and we use insertion sort to sort the elements of the buckets. So using insertion sort would shift the whole array to the right one to put an empty space in the front to put the smallest value, and then it would continuously do that for each iteration of the loop, making it n squared. And then the average runtime would be O of n. It's the same as the best runtime. When elements are distributed randomly, even without uniform distribution, the runtime is still linear. Bucket sort is mainly used on floats and integers. So if we have an array of integers, we could split up our buckets into ranges of these integers. So for this example, we have 1 through 10, 11 through 20, and so on. If we have just floats in our array, so no integers whatsoever, or like the same integer value with different decimals, you could split up the array into buckets for each 10th place decimal. So if we have 0.15, it would get placed into the 0.1s bucket, and so on. Bucket sort is best used when the input is uniformly distributed, as I said in the last slide. And then with buckets, you can assign sections of data by priority using these buckets if you need to use priorities later on in your code. And bucket sort is primarily used to speed up the sorting by breaking apart these long arrays of data into shorter arrays to sort faster.
Unlike some sorting algorithms like insertion sort, merge sort, or bubble sort, bucket sort is not stable on its own, as it depends how the inputs are sorted in their separate buckets. Once they are done sorting in the buckets, their order is not guaranteed to be retained. Two inputs with equal keys can end up not returning in the same final order. There is a close connection to stability, though, as an algorithm called radix sort is a variation of bucket sort. After placed in the buckets, bucket sort starts with the most significant digit through to the least significant digit, while radix sort has the ability to go in both directions. Bucket sort is also not in place as the inputs are moved from one list into different buckets. This means that they take additional spaces in order to be sorted. In some cases, the additional space necessary is as large as the original input array. Bucket sort, also known as bin sort, is an OK sorting algorithm to use. In the case of ordering input values using a fast hashing function, bucket sort would be the fastest method to use. But it is not stable in nature like some other algorithms, and would avoid using this unless necessary. Our final takeaway is that it does seem pretty inefficient to sort by splitting up the input array into several bins. Thank you for listening to our presentation about the bucket sorting method.